Today we're going to talk about creating an EKS blueprint to deploy Karpenter and then Kube Prometheus stack to monitor nodes provisioned by Karpenter. First, we're going to introduce Trackit. So we're like AWS partner. We have been in business for 80 years and most of our powers are media and entertainment, application modernization, high-performance computing, and cloud media storage. So we're gonna discuss about Karpenter, what is Kube Prometheus stack. We're gonna make a deployment demonstration and show you a Grafana dashboard. Before Karpenter, Kubernetes users needed to dynamically adjust the compute capacity of their clusters to support the application using Amazon EC2 autoscaling groups or Kubernetes cluster autoscaler. Nearly half of Kubernetes customers on AWS report that configuring cluster autoscaling using the Kubernetes cluster autoscaler is challenging and restrictive. So when Karpenter is installed in your cluster, Karpenter observes the aggregate resource requests of unscheduled pods and makes decisions to launch new nodes and terminate them to reduce scheduling, latencies, and infrastructure costs. Karpenter does this by observing events within the Kubernetes cluster and then sending commands to the underlying cloud provider's compute service such as Amazon EC2 or Fargate. Kube Prometheus stack is an Helm chart which installs the following components: Prometheus operator, Prometheus alert manager, Kube state matrix, node exporter, and Grafana. So this chart is formally named as Prometheus operator. So this stack is pre-configured to collect metrics from all Kubernetes component services, and additionally, this creates default set of Grafana dashboard and Prometheus alerting roles. So I'm going to present the demo part. In this part, we're going to look to the configuration and then deploy, and then we'll be able to go into Grafana dashboards. So first of all, we created the Helm charts to deploy Karpenter and Kube Prometheus stack. We're using Terraform to configure the all infrastructure, and Terraform is also going to deploy the Helm charts. We will need to create our Terraform backend. So the Terraform backend defined where Terraform stores state data files to keep track of the resources it manages, and this backend is defined by an AWS S3 bucket. Okay, so let's kind of show you here the provisioner with some of the requirements. So here we have choices. So let's say your workload has got the requirements of certain specific compute instances. You can define those instance types. So let's say we have about 400 plus different types of computer instances. If your workload requires, in this case, let's say for example, M5 large, you can define it. So you will use the provisioner, and if you want to limit your computer within certain specific availability zones in a region, you can easily do it as well. So it's really simple. And here we have a deployment. It's a simple deployment with 0 replicas. So here we have defined the replicas with a variable. So when you run the command terraform apply, you will have to put on the terraform tvars file the replicas that you want to put it. So we have deployed first of all with 0 replicas, and which I have deployed it, and this is a pose image on the public ECR, and right now and this is the name of the deployment inflate. Okay, so this is right. Now deployed with 0 replicas, what I'm going to take through is when we scale up the number of replicas of this deployment, right? I'm going to use some certain of numbers, so we're gonna put like 5 replicas, and that will give you an understanding how does Karpenter provision nodes. Okay, so first of all, you have to clone the GitHub repository with the command git clone and the URL of the GitHub repository. But since I'm already on the GitHub repository, I will directly run this command terraform init. Sorry. Okay. And then we're gonna apply our EKS infrastructure, and so we're gonna apply the Terraform configuration with the command terraform apply. It might take some time, so yeah, we have to wait, and I will show you the results after we apply the configuration. Okay, after we have deployed our EKS infrastructure and is applied, the Terraform is applied, the Terraform configuration is applied successfully, we will update our context in the region and with the EKS cluster name, and with this command. And then we're gonna okay. So before we're gonna before showing you the Grafana dashboard, I'm going to say something important. Okay. So here Karpenter is gonna provision EC2 instances or Fargate nodes. Okay, this is based on a variable that I created, and I have defined it here on variables Terraform file, and this variable is either false or true, so is a Boolean variable. Okay, and in my case I put Fargate false, so and worker node type that we're gonna put it on the compute type of core DNS add-on, and in this case Karpenter is gonna provision EC2 instances, right? And if you want Karpenter to provision Fargate nodes, the thing that you have to do is put Fargate on true and worker node type on Fargate value. Okay, so like you're seeing here, the nodes are EC2 instances, so get nodes. Okay, all right. And now I'm gonna show you the dashboard, the Grafana dashboard created, and for that we're gonna get the external IP of the Grafana service is under the namespace Prometheus stack. Okay. Sorry, I put the name of the namespace wrong. Okay, so here I put the service Grafana on a load balancer, and this is gonna be easier to access it from the external. And yeah, okay. I override the YAML file of the Prometheus stack, and this is it. How I have done it. Okay, so we're gonna copy this external IP, and so here I'm gonna paste the external IP of the Grafana service, and this is the interface that you get. Okay. I'm gonna show you the dashboards created when we have deployed the Kube Prometheus stack Helm chart. So there are dashboards already created, and I'm gonna show you some of these dashboards. Okay, so we have this dashboard is a dashboard that represents the CPU usage, for example, the CPU quota, the memory usage of pods running. Okay, and like we said before, that when I deployed the infrastructure, the EKS cluster, I have deployed also deployment YAML, right? And this deployment, I've set in this deployment, the infinite deployment replicas 0. So those are pods when the replicas are 0. Okay, Karpenter has provisioned those pods, those nodes, sorry. And those are all the pods running on those nodes. Okay, here we can select all of the nodes that we have in our cluster, and yeah, that's it. So thank you for watching, and hope you have understand this demonstration. And yeah, like I said before, I have put the GitHub repository URL down below the description, so you can understand it more and with the code. Yeah, and thank you.